So what are the attributes of complexity? Complex system consists of connected, also interdependent, those are different, which I'll explain, diverse and adaptable agents whose function collectively transcends the sum of its parts. So first of all, what I mean by agents here are, if you think about like in the global financial crisis, the agents were, in this case, individuals or companies. They could have been banks, they could have been mortgage lenders, or they could have been people, but there are a bunch of people that are acting independently in their own interest. So if you imagine a complex game in like a game theoretical context, you have agents of different types. They're diverse, meaning they're not just you don't just have variability within specific types. You actually have different types, different classes of actors, different agents. And the fact that they're all acting in their own best interest and interdependent and connected is what gives rise to complex behavior. So now let's think about this in terms of connectivity and interdependency. So if you imagine all the agents in a big network, I have two things that could contribute to complex behavior. One is how many connections do I have between agents? In other words, if I look at a big network graph, how many spokes are there in the graph? How many edges in graph theory? How many edges do I have between nodes? That's what connected means. Obviously, if you have more connections, you might wind up with different behavior. Interdependency, the difference between connectivity and interdependency is that how much effect does one of the agents have on other agents? It could be one agent or it could be multiple agents, but all of the agents in the system their actions are connected in an interdependent way. So in other words, they influence each other. Think about a social network. Think about in YouTube, you might have a YouTube influencer. You could draw, and there are tools to do this, but you can draw the network map of all the connections that this influencer, all the people around the world that person is connected to. And we'll talk about power laws. Those influencers today sort of replacing Hollywood back in the day, but these influencers have a social network that's directly influencing a lot of people in the node. That's what I mean by interdependent. I mentioned diversity. Now, diversity in the systems or complexity context, as I said, meant we talk about two types of, well, there's a difference between diversity and variability in a sense. Like I said, if I have agents, I could have variability within the agent. So to give an example, I mentioned in the GFC, maybe I have different types of brokers or different types of banks. I can have variability in what type of banks they are, like how well are they capitalized, or I can just think of other variability within a class of agents. By diversity, we mean we have different types of actors, as I said. And then the last and critical thing, which is usually the distinguishing feature of a complex system and complicated system, is adaptability. So these agents are, for lack of a better word, they're intelligent. They're acting intelligently based on, like I said, they have their own incentives. So based on changes in what is perceived as optimal, they will make decisions trying to go in the direction that is more optimal in their favor, but it may not be optimal for the entire system. Global financial collapse is a case in point. So how can we think about the distinction between complexity versus complicated? Well, here's the, you might think, I don't know what the brand of this is, but you think of a Swiss watch. This type of system, and by the way, is it a system? It's a set of interrelated components functioning together towards some common purpose of objective. That objective is telling time, obviously. Now, this exhibits a high degree of what I call tightly constrained order. What type of order is it? Well, I define the types of order. I claim that there are only 3 types of order. This is order type 3. The example that I gave was actually the watch. It's a cog in the watch. If I remove one of these cogs, the system doesn't work anymore. So that's what I when I say tightly constrained order, what I mean that everything is functioning together. So that's order for the sake of function. However, in this case, very tightly constrained, which is the opposite of robustness. And we'll talk about that. Okay, so I said it's as a the system is complicated. If you look at it, it is complicated. It's highly ordered, but it's not complex. Why? Why is it not complex? Let me go back to the definition here. Okay, so it's connected. The parts are definitely independent because I move one part, it influences another one. I have diverse types of elements, but this last thing is not adaptable. So because it's not adaptable, it can fail very easily.